Okay, so now I am going to be taking you through question number 5, where we will go through the statement and quickly attend to the questions. Trust me when I say, after you've done all these sessions, you will be a master of this topic. If you are not yet a master, it's a good indication that you need to try and do it again. So definitely, I do not intend to waste much of our precious time. It is for that reason we will straight away get into it. Question number 5, 5.1. This is what they want you to do: to consider the function having f of x, which is equals to negative 3 tan x. Consider the function f of x being equals to negative 3 tan x. Okay, so what do they want you to do? To sketch on the provided grid in the answer book. Even though in this case you are not provided, that means you will just have to neatly draw the Cartesian plane. So they want you to sketch the graph of f for that interval, meaning start from 0 and at 360 degrees. Clearly show all the intercepts and the asymptotes. I'm pretty much sure that you still remember what the intercepts are and what the asymptotes are. If you do that nicely and correctly, we will give you 3 marks. Most importantly, just need to make sure that it starts from 0, it ends at 360 degrees, and then you show where you are having your asymptotes being those broken lines. And then from there, very much important, very, very much important. I think I will need to just show you this one because it can be tricky sometimes to draw this type of a function. So you will do something like that. Let's say this is 90, 180, 270, 360. How do you know? Remember, these are your critical points. You do know very well by now how you find the critical points. And then from there, what else do you do? This is 360 degrees. Hold on. Is that really your critical points? I don't think so. Is that your critical points? Nope, because the critical points, we said how we calculate the critical points equals the, let's see, equals the period, you just divide it by 4. So the period for that function, it should be, period should be 180 degrees, and then you divide it by 1 equals 180 degrees. So that means we have 180 degrees that you divide it by 4. What will that be? It will be 45 degrees. Yes. So that means you have to have your 45 degrees, and then you increase that, and then that. So you will see why that 45 is important. Because remember, you are going to have, this is you can have, it doesn't really matter that much, 1, 2, and 3, negative 1, and then 3 there. So what you need to remember is that you will have to identify where you are having those dotted lines. So you see that you are having this first one at 90, and then you are having another one at 270. So when you start plotting, it may not be obvious whether from 0 you have to go in that direction or if you have to go in that direction. That's where that critical point will be very much important, because it will tell you whether to go up or down. And how you do it, that means you will punch that -3 turn off that 45 degrees. Then you check what value you get. Does it give you maybe +3 or -3? If it gives you -3, then you put a dot there at where x is 45 and then y is -3. Then you know for sure that from 0, it goes down like that. Can you see? Then you are therefore 100% sure that, okay, it is actually going downwards in that direction, and then somehow you'll find that it does that there. And then from there, you will know that it goes that. So it just follows that same shape whereby below that x-axis, it goes downwards towards the asymptote, but above it goes upward toward the asymptote, upward toward asymptote. It must just never touch or cross. So that is why the critical point, it is very much important. You see there, I just assumed those are the critical points because I confused it to be the function of cos and sine. But this is not the critical point. So the critical point, I'm pretty much sure that you've realized how critical it is, because that point will tell you whether you must go up or down. And for you to know, that means you will need one important point, which is that 45 degrees and -3. For that reason, you know that it actually goes down. Very much important, the honorable member. Okay, now 5.1.2, they want you to find the period of f. We've just calculated it. It should be that one. Explain, nope, equation of h if h is reflected, if h is the reflection of f about the x-axis. You remember, we said when it comes to a reflection, you just change. So that means this thing being y equals to -3 tan x. When it reflects about the x-axis, you just change that sign for the amplitude. So that means it will now be y equals to +3 tan of x. How does a reflection look like on the graph? This is how it looks like. If you had to plot that reflection about the thing, that means it's like you've just reflected it and now it does that. That's how a reflection would do. Think of it flipping the whole of that. That means now this one is now going like that, and then that is going like that. And then on that other side, you would not see because it will be a, well, oh yes, you will definitely see because now it will be going down like that. That would be the reflection, is it G? No, F. So that would be F slash there. That would be the image or the reflection of that. Okay, so I think that one, it is clear. You've given the equation, but remember that equation as you give it, it has to be h of x because they specify to say the equation of h. Very, very much important. Excuse me, worry not. You are very, very far from where I am, the honorable man. Very, very far. I can even go for the second sneeze. You are very much safe. Okay, looks like I might need to just remove all of that because it looks like we are now diving into a complete new question. So we are done with that one of the tan function. So tan function, it just looks a bit scary, but trust me when I say it is not that much difficult. You just need to make sure that you focus, and that's all that you need. Okay, so now they are saying sketched below is the graph of that. Okay, we are having the graph of that. Definitely they will want us to find the A and the B. Now they say write down the values of A and B. When it comes to A, I don't know why, I will never fail to get A because A being the amplitude, it is half of that maximum value combined with the minimum value. It ends up half of 4, which is 2. That's how you get your amplitude. Can you see? And then when it comes to B, B is in that position, if you remember, where we have that formula which says the period of that function is raised 60 that you divided by B. And we know that the period for that one, of course, it is that one of 360 degrees, which should be equals to 360 degrees over B. You cross multiply, you divide by 360, it's like B equals to 360 degrees over 360 degrees. And that is why you get your B value to be equals to 1 for that one. Yes, okay. Then now they want you to use the graph to determine the values of x for which g of x is above 0. It's like they want to know between which x values do we have that graph of g above 0. So let me show you so that you understand. This section of the graph, it is above 0. But that section of the graph, it is below the 0 line. Can you see? So, it is exactly at that point where it is 0. Exactly that point where it is 0. So the question did not say where g of x it is greater or is equals to 0. They just said where g of x is greater than 0. That's why even when you answer, you will say actually between 90 and 270. It is between that section whereby you are having that graph of a g being above 0. All the y values are above 0, or they are positive. They are greater than 0. So in answering the question, you will therefore say it is where x is between 90 degrees and 270 degrees. That's where that graph of g is above that. Can you see? But if the question said where g of x is less than 0, they are looking for the green part now. So for the green part, you would therefore say between 0 and 90. In other words, you are saying it is that section whereby g has negative values, or that g function has negative y values. And then again, you will still say between 270 degrees and 360 degrees, which means between that section, that's where you are having that graph being below that. So when you interpret this question, think of it as they want a section of that graph. If it's greater than, you know that above that 0 line. If it's less than, you will know that they are talking about that section of the graph which is below that 0 line, something of that nature. Okay, now they say determine the range of h if h is the image of g, if that g is shifted down 2 units. Let me just erase again so that you will have an idea of what's happening there. So you see, this thing is about this thing reflecting about the x-axis, and then sometimes it can undergo simultaneous changes where it now reflects after reflecting, and then it shifts. But in this case, it looks like it is only shifting. So that would mean determine the range of h if h is an image of g, and that g shifted down by 2 units. So that means it will shift -3 to -4. It will shift up to there. And then there it means it will go down by 1 and then not from there, but we count from 1 to say it shifts to there and then it shifts to there. So that means it will make now a U-turn there at 0. So that means this function, if I have to do it as a dotted line, it would be something like that. Something like that. Can you see? There's a shift by 2 units. That means the difference between each point is 2. So that means there is that shift of 2 units. Everywhere, that difference must be a shift by 2. So can you see now that the new range, it is ranging now within or between 0 and that -4. It will just depend on how you write it, whether you say between -4 and 0, or you do that one of y is the element of -4. You start with a smaller value and then a bigger value. Remember, between -4 and 0, the bigger value is 0. That's why you have to write it in that way. So that's how you would work it out, the honorable member. And I'm pretty much sure that you did understand all that I've explained there. For that reason, I will just leave it there. Definitely say until